If you are given a rectangular beam, how do you find the second moment of area? The second moment of area about the x-axis will simply equals to what? Using the parallel theorem, this will be base multiplied by depth, then cubed, divided by 12. Then the second moment of area about the y-axis, about y, this will be equals to b cubed depth divided by 12. What about the solid shaft or the circular shaft? Our I will be the same throughout. This will simply equals to what? Pi over 64 multiplied by diameter raised to the power 4. So Ixx will simply equals to Iyy. Alright, so when you're given the hollow shaft, if you have given a hollow shaft, obviously we'll have the internal diameter and the external diameter. Alright, so this will simply our second moment of area will be equals to pi over 64. Then this will be multiplied by d raised to the power 4 outside diameter minus the inside diameter, since it's what? It is a hollow shaft. This is how you go about to determine the second moment of area. And all these, they are measured in what? In meters raised to the power 4. The moment of area, second moment of area, is given how its SI unit is measured by meter raised to the power of 4. That is how you go about determining the second moment of area of the types of beam. Remember, in cross-section that you consider, if you have given rectangular cross-section, you use this. You have given the circle or solid shaft, which has a circle cross section, you use this formula, and then it's equal from Ix axis and y, it's the same.